Hi and welcome to Standing Yoga. We have 10 different exercises. These 10 exercises are the crab in the morning, the reed in the wind, the moderator, a bit of a warrior, standing cat and cow, the triangle, the chair, the sun god, the stork, and the garden pose. And in between these 10 exercises, we're trying to learn a bit of meta wave from quantum mechanics. So a bit of meta wave of quantum mechanics, some info snippets. And participating in the exercise is at your own risk. So let's start with the first exercise, the crab in the morning. We have the feet standing a bit more than shoulder width apart. And we breathe in and bring our arms up. And we breathe out and we bring the arms back. We're leaning back and we open the chest to the sky. And we breathe in and are coming up again into the middle. And we breathe out and now going again back. And breathe in. And one more time out. And in. And the arms come down. Now to the first info snippet to meta wave. So it's that the theory of quantum mechanics exists. So there is a theory and it is the theory of quantum mechanics. The second exercise. Now we have the feet standing together. We breathe in and bring our arms up. It's the reed in the wind. We breathe in and we breathe out and we're leaning back. And breathe in again. Come back into the middle. And breathe out and lean again back. And breathe in. Back into the middle. And one more time. Breathe in. And out. Back into the middle. And out. That was the reed in the wind. So, first info snippet to meta wave was that the theory of quantum mechanics exists. And the second snippet is meta waves are a central part of the quantum mechanics theory. So these meta waves are a central part of the quantum mechanics theory. Our next exercise, one snippet more. Meta waves means that meta exhibits wave-like behavior. Now the moderator. We have feet standing together, we are tall up, and we lean forward, not completely together maybe, with toes, and going a bit on the forward part of the foot. We don't have to go completely, and now we're leaning back, we don't have to go completely onto the toes, just the weight on the forward half of the foot. And back, and the weight on the heel. And again in front. So, meta wave means that meta exhibits wave-like behavior. So meta displays stars wave-like behavior. And that was the moderator. And now, a light beam can be diffracted from its original path. A beam of electrons can be also diffracted from its original path. So a light beam can be diffracted from its original path. A light beam comes and can be diffracted away. And also electrons can be diffracted from the original path. Now the next exercise. We have one leg out with the toes pointing to the outside, a bit in front, and the other leg with the toes in front or maybe a bit to the inside. And now we lift our arms, we breathe in, and we breathe out and we're going down. We are bending our knee which is in front. And now we breathe in and are coming a bit up with the knee. We straighten that leg a bit. And we breathe out and bending it again. And now we breathe in and out. We're laying the arm onto that leg and we're bringing that arm over. And we look up. And keep breathing calmly. And we're coming back into the warrior. We breathe in. And now our hand goes down, slides down the leg, and the other arm comes up, and we look up. Now we breathe in, and again straighten our bended knee a bit, and out, and are bending our bended knee again. And we come back to the warrior, and exiting the warrior. Wave-like behavior was first at Electrons Demonstrated. That was in 1927, and I skipped one. The concept that matter behaves wave-like was proposed by Louis de Broglie in 1924. not on the other side of the warrior. Again, the toes are pointing straight forward, maybe to the inside, and these to the outside, and we're going into the warrior. So in 1924, Louis de Broglie proposed this idea, this concept, and we straighten a bit our leg, and breathing out and going again into the warrior. Louis de Broglie proposed in 1924 this concept that matter behaves wave-like. And now we breathe in, and out. We are laying again our arm onto the leg, and we bring our arm over, and we look up. In 1924, Louis de Broglie proposed that matter behaves wave-like, and in 1927 it was demonstrated experimentally at Electrons. We're coming back into the warrior, and we breathe in and out. Now bring our arm over, and the right arm slides down. And we breathe in and straighten our bend knee a little, and out, and we bend it again. And we're going back into the warrior, and we're exiting the warrior. Besides of electrons, wave-like behavior was also demonstrated for elementary particles, neutral atoms, and molecules. So not only electrons do this wave-like behavior, but also elementary particles, molecules, and neutral atoms. The matter wave has a wavelength. So there's a length of this wave, of this matter wave. And that can be calculated. But first it has a wavelength, and the wavelength is lambda. And the particle doing the matter wave has a momentum named p. So the particle which does, for example the electron, has a momentum p. And the Planck constant exists and is named h. It's just a Planck constant and it has the letter h. And electrons, neutrons, and atoms have different wavelengths. So not all particles have the same wavelength. Now, standing can go. We are going down, placing our hands on the knees, and we breathe in and out, and we hollow our back, hollow our chest, and breathe in again, coming into neutral position, and out and coming into cat position, and opening our chest, and we breathe in again, and out and hollowing our back, and breathe in again, and out, back into cat, and one more time in, and out and hollow into cow. No, it's the cat. We breathe in, and this is the cow. Now we breathe in, and out, and we're coming up. And the matter wave's wavelength can be calculated by dividing the Planck constant through the momentum of a particle which is doing the matter wave. So the wavelength, lambda, is the Planck constant h divided by the momentum p. Lambda equals h divided by p. And now the triangle. We have, similar to the warrior, one leg standing, both legs are straight, these toes are pointing in the red direction and back into red. And we are lifting our arms, and now we're shifting over as far as we can. Now we're going down, and we're looking upwards. And we're going back, turning the position of our feet, these pointing in the this direction and maybe in the red direction. And we're shifting again forward as far as we can, and down, and we're looking upwards. And we're coming back into the middle. That was the triangle. Now, the concept of matter waves is used in the study of material. So that matter has matter waves, is used when we study materials. Now the chair. We are bringing our arms up, with the feet standing together, and we breathe out and are going down into the chair. When they're completely together, we have an inch of space between the feet. Now we're coming onto our toes. And we're going completely down. Do this only if you can do it without bending your knees. Now we're going to come up in one straight line. We keep standing on our toes. Coming up. And we're coming down again. We keep standing on our toes. Now we're going to come up finally. Take arms down and also our heels. Now the next exercise, we have all snippets. The sun code. So we have the legs standing wide apart. We are bringing our arms up, turning the palms to the sky, and we're bringing our hands to touch over our head. We breathe in, and we breathe out, and we're bending our knees and going into squat. Now let's lift the left heel, and bring it down onto the ground. Let's lift the right heel, and bring it down onto the ground. Bring our arms down, and we're coming up, and we're going down again. And we're coming up, and down. Straighten your arms again, and bring the palms to touch again over the head. We're coming onto both toes. Coming up, arms come down, heels come down. Now, the stalk. So, we are lifting one leg and placing one hand on the knee and opening to the outside. Now, if you feel like it, you can do the ambitious stalk. You take the toes and straighten the leg and bend out to the other side. And now we're going to go down and the leg comes down. You can do it with the other leg. So the leg comes up, taking hold of it and up to the outside. And again, if you feel like it, take the toes, straighten the leg, up again to the outside. Take the leg in and down again. Now the garden pose. We have toes pointing to the outside and ulnar length space between our heels. We breathe in and bring our arms up and out, and we're going into the garden pose and we're placing our elbows against the inside of the knees, pressing against them, and we breathe in and straighten our back. So meta waves. Louis de Broglie proposed in 1924 that matter behaves in waves, and in 1927 it was proven at electrons, even also at elementary particles, neutral atoms and molecules. Now, going for our back up, and we close our feet. We're coming up halfway into the monkey half, and we're going down again. One more time, halfway up, straighten your back, and for the last time down. And now we up, flapping swan, closing our hands above our head, and we're done with the standing yoga. And light beams and also electron beams can be diffracted from the original path, and the wavelength of these matter waves can be calculated, and the wavelength is lambda, and this matter has a momentum, and that is p, and the Planck Constant exists, and that has the letter h. And if we want to know the wavelength of these matter waves, then we have to calculate, so h divided by p. So the wavelength, lambda is h divided by p. Lambda is the wavelength. And these matter waves can be used to study materials. And I think that were mostly a summarizing of the info snippets to the matter waves. This was the standing yoga. Thank you very much, and until the next time.